This is Math 0030, Section 2.3, Solving Linear Equations. So in the first, we're going to take a real-world example. In Massachusetts, the speeding fines are determined by the formula F equals 10 times the quantity x minus 65 plus 50, where F is the cost in dollars of the fine if a person is caught driving x miles per hour. So we're going to use this formula. If a fine comes to $400, how fast was I going? Well, my formula is 10 times the quantity x minus 65 plus 50 equals 400. So I want to get the x by itself, but first let's subtract 50 from both sides. So now 10 times the quantity x minus 65 equals $350. I could distribute this 10 through the x minus 65, but since the 10 is multiplying the whole quantity, I'm going to go ahead and divide both sides by 10. My 10's cancel here, and I'm left with x minus 65 equals 350 divided by 10 is 35. And just to move this up here so we have a little more room, x minus 65 equals 35. If I add 65 to both sides, x equals 100. So if I'm traveling 100 miles per hour, it's going to cost me $400 if I get pulled over. So to simplify a linear equation, first we're going to simplify the algebraic expressions on each side, collect all the variables and terms on one side, all the constant terms on the other side, isolate the variable and solve, and then we can check the proposed solution back into the original equation. So for our speeding example, if I take 10 times 100 minus 65, close my parentheses and add 50 to it, I better get an answer of my $400 fine. So let's run through these first examples here. I've got a negative 7x plus 25 plus 3x equals 16 minus 2x minus 3. I'm going to go ahead and combine like terms on my left side, which is going to give me negative 4x plus 25 equals 16 minus 3 is 13 minus 2x. I'm just going to go ahead and put my x's on the left side. So to get rid of this 2x here, I'm going to add 2x to both sides. So negative 2x plus 25 equals 13. To get this 25 away from the left side, I'm going to subtract 25 from both sides. So negative 2x equals negative 12. Divide both sides by negative 2, so x is going to equal positive 6. For b, I have 8 equals 2 times the quantity x plus 6. I can go ahead and divide both sides by 2. I could distribute, but it's 6 of one, half dozen of the other. 8x divided by 2 is 4x equals x plus 6. Subtract x from both sides to get my x's isolated on the left. 3x equals 6. Divide through by 3, and x is going to equal 2. Here I've got 4 times the quantity 2x plus 1 minus 29 equals 3 times the quantity 2x minus 5. There really isn't an advantage to trying to divide through at this point. It would just get ugly. So I'm going to go ahead and distribute. That's going to be 8x plus 2 minus 29 equals 6x minus 15. I can combine my like terms over here. Excuse me, that's going to be 8x plus 4. I don't know where the 12 came from. So I can combine like terms on this side. That's going to be 8x minus 25 equals 6x minus 15. I'll have the x's, I want them on the left side. It doesn't matter which side, but if I put them on the left side by subtracting 6x from both sides, I end up with a positive 2x minus 25 equals negative 15. I'm going to add 25 to both sides to isolate my 2x here. So 2x equals 10. Divide through by 2, and x equals 5. So go ahead and pause the video and try the 3 practice problems. Okay, my first one, x equals 10, x equals 2 for b, and x equals 6 for c. Next, we're going to talk about clearing equations with fractions, when we begin by multiplying both sides of the equation by the least common denominator, of all the fractions in the equation, the least common denominator is the smallest number that all denominators will divide into. Multiplying every term on both sides of the equation by the least common denominator will eliminate the fractions in the equation. So here I have a 2 and a 5 for my denominator, so my least common denominator would be 10. I'm going to multiply everything by 10 over 1. 3x times 10 is going to leave me 30x. 2 times 1 over 2 equals x times 10 is 10x over 5 minus 390 divided by 5. 30x divided by 2 will leave me 15x equals 10x divided by 5 is 2x minus, and I'm just going to grab a calculator, 390 divided by 5 minus 78. Notice now I have eliminated all the fractions in my problem. I can subtract 2x from both sides. I get 13x equals negative 78. I divide both sides by 13, so x is going to equal, if I do negative 78 divide by 13, x equals negative 6. For my next problem, I have a 4, a 3, and a 6, so my least common denominator is going to be 12. X times 12 is 12x, 4 times 1 is 4, equals 2 times 12 is 24x, over 3 times 1 is still 3, plus 5 times 12 is 60, 6 times 1 is 6. I can simplify each of these fractions. 12x divided by 4 is going to leave me 3x equals 24 divided by 3 is 8x plus 10. I'm going to go ahead and leave my x's on the left side, subtract 8x from both sides. I get negative 5x equals 10. Divide both sides by negative 5, and x ends up equaling negative 2. So solve the equation and try the 2 practice 2 problems. First one is x equals 20. The second one is x equals 15. I can do the same thing if I have decimals. It's not necessary with a calculator, but by multiplying a decimal number by a power of 10 has the effect of moving the decimal place to the right. So 0.3 times 10 is going to give me 3. 0.37 times 100 is going to give me 37. And 408 thousandths times 1,000 is going to give me 408. Again, you could do this with a calculator, but let's go ahead and try clearing out the decimals. I have 3/10 times the quantity x minus 6 equals 37 hundredths times x minus 1.1. So I'm going to go ahead and multiply everything by 100. 0.3 times 100 is 30 times x minus 6 equals 37 hundredths times 100 is 37x minus 110. Distribute my 30 through, so that's going to be 30x minus 180 equals 37x minus 110. I'm going to go ahead and I've got 30x on this side, 37x on that side. I'm going to have my x's on the right side just to keep everything positive. So subtract 30x from both sides. I get negative 180 equals 7x minus 110. I add 110 to both sides to get rid of my 110 on the right. Excuse me, I add 110. So I end up with negative 70 equals 7x, divide through by 7, and x equals negative 10. Sorry, ran out of room there. For problem B, I have 48 hundredths x plus 3 equals 2/10 times the quantity x minus 6. Again, let's go ahead and multiply by 100. 48 hundredths times 100 is going to give me 48x plus 3 times 100 is going to give me 300 equals 0.2 times 100 is going to give me 20x minus 6. I'm going to go ahead and distribute my 20 through here. So I still have 48x plus 300 equals 20x minus 120. I'm going to subtract 20x from both sides, which is going to leave me 28x plus 300 equals negative 120. Subtract 300 from both sides. 28x equals negative 420, which seems as good a time as any to grab a calculator. Negative 420 divide by 28. And just to make sure I'm showing my work here, divide by 28 on both sides. X equals negative 15. So go ahead and try the practice 3 problems on the next page. Pause the video and unpause when you're done. For the first one, x equals 20, and on the second one, x equals negative 2. So far, we've been dealing with one solution. There's a possibility that we could end up with no solution, or in fact, we could end up with all real numbers. So if you attempt to solve an equation with no solution or one that's true for every real number, you're going to end up eliminating the variable. An inconsistent equation with no solution results in a false statement. I get something that can't be true, like 2 equals 5. An identity that's true for all real numbers results in a true statement, such as 4 equals 4. So let's take a look at our first example. Does 3x plus 7 equal 3 times the quantity x plus 1? Well, to start, let's distribute. 3x plus 7 equals 3 times x is 3x plus 3. Well, 3x plus 7 can equal 3x plus 3, but let's run through the process here. If I try to get rid of the 3x on my right side, I'm going to subtract both sides by 3x. 3x minus 3x is 0. 0 plus 7 is 7 equals 3x minus 3x is 0 plus 3 is 3. 7 can't equal 3, so there is going to be no solution. These two cannot be equal. For my next example, I have 3 times the quantity x minus 1 plus 9 equals 8x plus 6 minus 5x. So let's go ahead and distribute our 3 through here. So 3x minus 3 plus 9 equals 8x minus 5x is going to be 3x plus 6. If I combine my like terms on the left side, I get 3x plus 6 equals 3x plus 6. Well, that's pretty much obviously true, but let's get rid of the 3x on this side by subtracting 3x from the right and 3x from the left. 3x minus 3x is 0 plus 6 is 6 equals 3x minus 3x is 0 plus 6 is 6. So in this case, the answer is all real numbers. No matter what value I put in for x, at this point, if I multiply it by 3 and add 6, I'm going to get the same thing on both sides. As opposed to my left equation where I have 3x plus 7 equals 3x plus 3, no matter what I put in for x, I'll never get a true statement. So go ahead and try these 2 practice problems and unpause the video when you're done and check your answers. So for practice 4, you end up with 6 equals 8, so there's no solution. And for this right equation, you end up with 5 equals 5, so it's true for all real numbers. So go ahead, stop the video, do the 2-3 homework in my math lab,